So students, this is the second class on bending moment and shear force. So the last class we have discussed about how to find out the shear force and how to draw the shear force diagram of a cantilever beam under concentrated and uniformly distributed load UDL. Now let us find out the bending moment also. Okay, so what is meant by bend? What is moment? Moment is always represented at a point. So moment at a point is equal to force into perpendicular distance. That is meant by moment. That is, if I am having a cantilever like this, if I am having a cantilever like this, again a force of 10 kilonewton is acting at a point B, A, B. Let these points be C. Now let it be 1 meter, let it be 2 meter, etc. Okay. Now there can be moment at each and every point. So moment at point B, let it be MB. MB is equal to, again, what is the moment here? Force into, what is the force? 10. 10 into what is the distance? Moment means it is the at the perpendicular distance from that point. So here what is its distance? Is 0. So that is 0. Now moment at C is equal to, moment at C means it is at this point. So here we are considering this is the point C, then that is force. Force is 10 kilonewton. 10 kilonewton into what is the distance? Distance is a perpendicular distance, that is this distance. It is 1 meter. So 1, that is 10 kilonewton per meter. That is the moment at C. Again, what is the moment at A? Moment at A will be 10 into, that is the force, 10 into distance means it is the perpendicular distance, that is this will be the distance from this point. That is again that will be 10 into 2 plus 1, that is 3, 30 kilonewton meter. So these are the moments at the moment at B is 0, moment at C is 10 kilonewton per meter, and moment at A is again it is 30 kilonewton per meter. Now you have to understand the sign convention also. That is here you can see, if I am considering a section, if this is a beam, then it is having a moment. Let this, there will be a section, and I am considering the section XX. If the total moment is like this, in the right of section it is in the, what is this direction known as? This direction it is the clockwise direction. If the right is clockwise, and if considering left it is anti-clockwise, it is negative, and that is known as hogging moment. And if this is a beam, if the right of the moment is like this and left is like this, right is clockwise, anti-clockwise, and left is clockwise, it is positive, it is known as sagging moment. So in a cantilever beam we will be having a hogging moment, and hogging moment it is negative, sagging moment it is positive. Okay, now let us consider here. So this was the beam which we have considered. This is the beam which we are considering now. So here the 10 kilonewton was acting. Now at this point the moment is equal to 0. Now at this point C, so I am considering this. So the moment can again, moment means bending moment can be found out by considering the forces to the right or left. Either you can consider forces to the right or left. So in a cantilever beam, just always consider to the side, to the free side only. Okay. Again, last class also I have told that this right and left you will understand more when you are taking a simply supported beam or a overhanging beam, then you will be getting the idea about this. But in a cantilever beam, just take the section to the free end. That will be very easy. Okay. Now here I am considering. So this load is there, and this load will be acting like this is the line of action of the load. It is the downward. So what is happening here? Here this means moment means what? It is a force. So this portion, it will be moving to this direction, right? Like this it will be moving. Okay, to this portion it will be moving. So since this Okay, like this it will be moving. So like this only the force will be acting. So what is happening? The right of the section is moving in the clockwise direction. So such a there we will be giving it as minus, negative sign is given. So that is given here. Look at here. The right of the section is clockwise, then it is negative. Or left. If I am considering the left, it is moving upwards like this. If I am considering the here, this is negative, and negative moment is known as hogging moment. A hogging moment can happen in a cantilever beam, or a overhang beam also there will be hogging moment, or fixed beam there will be hogging moment. So that we will be discussing later. So now we have to draw the shear force diagram. So bending moment diagram, sorry. So bending moment diagram I am drawing. So here I am having a beam. Now here it is 0. Now it is at C, what is answer? Minus 10. So at C it is minus 10, at D it is 30. So like this. How can I join this? This can be joined by using a straight line. Okay. That is, this is the bending moment diagram, BMD. We are representing it as BMD also. Now let us take into consideration a real problem. Okay, that is, I am having a beam, cantilever beam. Okay, there are two loads are acting. Okay, this is a simple problem only. 10 kilonewton and 20 kilonewton is acting. Now let the distances be 2 meter and 3 meter. This is A, B and C. So here I have to find out the shear force diagram and bending moment diagram. I am doing it together. So first one I am taking shear force diagram. So first one, in order to find the shear force, first I have to find out the shear force at the various points. Shear force at C. What is the shear force at C? Again it is 10 kilonewton. Again, what is the direction? It is downward. Therefore, right of section is down. It is positive. Then shear force at B. What is the shear force at B? So I will be considering a section to the right only. So what will be the answer? Plus 10 plus 20. That is equal to 30 kilonewton. Then what is the shear force at C? Sorry, shear force at A. A will be at this point. It will be again 10 plus 20, that is again 30 kilonewton. So if I am drawing this shear force diagram, here it will be 10, here it will be 20 and again 20. Therefore my figure will be like this. It will be a rectangular figure. So this is my shear force diagram. Okay, 10 kilonewton, and the values you have to write, it is 30 kilonewton. Okay. Now next one, it is the bending moment diagram. So in order to draw the bending moment diagram, first of all I have to find out the bending moment at salient points. Salient points is here we are having 3 points, C, B and A. Mainly we are finding out the bending moment under the concentrated loads. Whenever there is a concentrated load, the bending moment will be changing. So like that points only we will be finding out the bending moment. Some other also conditions are there. If the width of the section is changing or depth is changing, also we will be finding out. So the bending moment at C. Bending moment at C. What is BMC I am taking? Bending moment C is equal to 10 kilonewton is there. But what is the distance? It is 0. Okay. So 10 into 0, that will be 0 kilonewton per kilonewton meter. Now bending moment at B. What are the forces? If I am considering this bending moment at B, so this is the bending moment I am considering to this section. What are the loads? To 10 and 20 is there. But 10 it is having, let's understand, it is coming downwards. That is clockwise. So I am taking minus of force into distance. What's the distance? 10 into 20. Then again, what is another force is there? Minus, again that is also downward. 20 into, what is this distance? It is 0. That force is 0. So that our answer will be minus 20 kilonewton meter. Now, the bending moment at A is equal to, what will be the bending moment at A? Minus 10 into First one, this due to this there will be two forces. That is, one it is this force and second is this force. So first one I am considering from this point, from A. What is the distance to this force, perpendicular distance? 3 plus 2, 5. That is minus 10 into 5. Minus, again minus is taken because it is hogging moment only. Minus 20 into, what is that distance? 20 into this distance. From this point to, from point A to B it is 3. So what will be the total force? 10 into 5, that is minus 50, minus 60, it will be minus 110 kilonewton meter. So this is the things which we have obtained. So again I am drawing the bending moment diagram. So at this point C it is 0, at point B it is 20 kilonewton. I am marking, other one it is minus 110. So how can I join this? By just using this straight lines I can join this. So this will be my, so here it is, just write the values also, 20 kilonewton meter. Here it is 110 kilonewton meter. So it is negative. Negative means it is in the hogging moment. So in a cantilever, negative bending moment will be there. That is meant by hogging moment. Okay. So this is a way in which we can find it. Now let us take another example. So I am having a combination of loads, or before the combination of loads, let us I am considering a UDL. Okay, a simple UDL. Let that be 10 kilonewton per meter and let the total distance be 2 meter. So first of all I am drawing the shear force diagram. So the shear force, there are only 2 points, A, B, middle point also I am taking, A, B, C. Okay, just taking the middle point, no need of taking the middle point, you will understand. So the shear force at B, it is again at this point it will be 0 because 10 into 0, 10 kilonewton 0. Then shear force at C, what will be at C? 10 into distance 1 meter, that is 10. Then shear force at A, it is again 10 into 2, that is 20 kilonewton. This is 20 kilonewton. So how can I join? Here it will be 10, here it will be 20. I can join like this. Okay, so this is my, it will be a positive only. So 10, 20, so this will be my answer. So it will be positive moment. Here it will be 10 kilonewton and here it will be 20 kilonewton. This is my shear force. This we have discussed. Now that is a bending moment. So bending moment at B, again it is 0 because the load into that is. Then bending moment at C. Bending moment at C. Okay, that you have to understand. What is a bending moment at C? That is a load into, either I can take the right or left. I am taking the right. Right of the section is taken. Therefore the load is 10 kilonewton per meter. So the load will be 10 into, so the load moment is always, what is moment? Just a minute. So the moment is, what is load into perpendicular distance. So what is the load here? It is a UDL. So the load will be 10 kilonewton per meter into, in order to convert a load you have to multiply it with the distance, that is it will be 1. This is the load into, what is the perpendicular distance? That is, for a UDL this load will be acting at the center. Center means here, since it is the load, that is 1 meter, this is 1 meter. So this load, so the total load will be 10 into 1, 10 kilonewton. And this load will be acting, we are assuming it is acting in the center because it is a rectangle. A UDL, it is always a rectangle type of loading. So what is, so in the centroid only that load will be acting. So we are assuming, we are finding in that way. That is, we are finding out the total load, and that the total load will be acting. That is, for example, if I am having a rectangle like this, rectangle loading like this, This loading, this will be 10 kilonewton, and that this distance will be 1 meter. So this load is equivalent to a point load which is acting at a distance of 0.5 meters at the center. These two loads are equal. The same concept is used here. So here this 10 kilonewton is acting at this point middle. So that is at a distance of 0.5 meters. Therefore here the point will be 0.5. That will be 10 into 0.5, 5 kilonewton meter. That is the bending moment at B. Now what is the bending moment at A? That is the bending moment at C. Okay, bending moment at B is 0. Bending moment A means at this point. At A means at this point, what is the bending moment? So again I am drawing once more. I will draw. That is, this is my load. And this is A. So here the total load will be 10 kilonewton. The load is the load is 10 kilonewton. So the total 10 kilonewton per meter. Total distance is 2. So what is the load? The equivalent load will be, it will be acting at the middle. Okay, that load will be 10 into 2. That is 20 kilonewton. This will be acting at a distance of, what is the 1 meter. Total is 2 meter. So this is the assumption. Therefore what will be the moment? Moment will be load. Load is 10 into 2 into perpendicular distance, that is 1. That is again 20 kilonewton meter. So the moment is 20 kilonewton meter. Okay. So we have found out the moment at moments at B and C. So how can I draw that? Here all the moments are negative. Therefore here it is 0. At point B it is 5, and here it is like this. So I can join like this, and this will be my bending moment diagram. Okay, that will be my bending moment diagram. Again, let us consider a small problem. Similar problem here. I am having a beam, a cantilever beam is there, and here there is a load. Here again there is an UDL. Let it be 10 kilonewton. Let this be 2 kilonewton per meter. Let the distances be marked as 2 meter, 1 meter and 1 meter. Okay, I'm just taking the distances. Let the points be A, B, C and D. Okay, the points are taken. So first of all, the bending moment we have, shear force we have drawn. I am now drawing the bending moment. So first one, bending moment at, let us take the bending moment at this point D. So the bending moment at D is equal to, what is the bending moment? Here there is any force is there? No. Therefore bending moment at D will be 0. Now bending moment at C. Bending moment at C. Again, I am considering this section only at C. To the right or to the left. To the right I am considering, is there any force? No. Again that will be 0. Only one force is there, that is 10. 10 into that distance is 0. Therefore it is 0. Now bending moment at B. Bending moment at B will be, this is the point. This is the point. So I am considering this one. From here, what is the load? There is a 10 kilonewton. That is to the, it will be rotating like this. This load, if I am considering this will be rotating like this only. Okay, coming. That is in the clockwise direction. So clockwise direction we are taking it as negative. The right of section is taken as negative. So minus of, what is the load? 10 into, what is the perpendicular distance? This is the perpendicular distance. This one. That is 1. 10 into 1. That is minus 10 kilonewton meter. That is bending moment at B. Next, last one, it is bending moment at A. So let us consider the bending moment at A. Bending moment at A means there are two loads. First load, it is this one, 10 kilonewton. So again that is in the clockwise. So minus of 10 into, what is the perpendicular distance? From this point to this point. You can just see this arrow. So what is the distance? 2 plus 3. Perpendicular distance is 3. Then minus, what is the next load? We are having a UDL of 2 kilonewton per meter. So first of all, you have to convert into load, that is 2 into 2. So that is the total load. Now you have to consider per direction where it will be acting. So here let us consider. So this 2 into 2, this will be acting at the center of this one. Okay. So the perpendicular distance is from A, it is this distance where it will be 2. This total is 2. Therefore the distance will be 1 meter. It will be acting at a distance of, that will be the lever arm into 1. So this will be our, that is minus 30 minus 2 into 2 into 1, that is 4. That is minus 34 kilonewton meter. So this will be the bending. So just to understand, bending moment at D, it is 0 since there is no load here. At C again it will be 0. It is 0 because of what? Only one load is there, that is 10 kilonewton. 10 into 0, that is the reason why it is again 0. Bending moment at B is equal to this, from this point to this. It is 10 into 1, that is minus 10. Minus is taken as negative. Then next, last one it is, here we are having the last one, it is here 10 into 3, that is 30 minus this load 2 into 2, load will be 2 kilonewton per meter into 2, that is 4 kilonewton into the distance, that will be 34. So the bending moment will be like this, that is here it is 0, at C it is again 0, then at this point it will be at the point B. At the point B it is 10 kilonewton per meter, and here it is 34 kilonewton meter. And now we will be joining like this. So this will be the bending moment. And one thing you have to understand is that here, that is an important thing you have to understand. Here I have joined like this joining, it is not in a straight line. You have to join this in a parabolic way. This is a parabolic variation, not a straight line. Because why? Because here you just understand, here we have here, what is the moment? We have this moment 20 kilonewton. How we are finding out? That is 10 into 10 kilonewton per meter into is into the distance. The distance is 2 meter into, again we are having another 2 is also there. So that is the reason we will be getting the equation yx square or mx square. mx square is there. So since x square term is coming, therefore we have to take the variation will be a parabolic variation. Okay, that is the thing you have to understand. So here it is a parabolic variation. Okay, I will once again I will explain that. So here you can see, just understand, here this is a straight line. This is a parabola. Why I have taken this? Because let us take a small example. I am taking a cantilever beam. Cantilever beam is taken. Okay, and it is having a UDL like this. Let that value be W kilonewton per meter. Now I am considering a section XX at a distance of x, small x. Now the moment at this point, the moment at XX is equal to, first one load. What is load? W into x, that is a load. Now again, moment means load into distance. This load will be acting, W into x is the total load. That load will be acting at a distance of half from this, at the middle. What is the middle? X by 2. X by, sorry, it will be so x by 2. That is equation will be Wx square by 2. Okay. So here you can understand y is equal to m. It is a constant line. Y is equal to m into x. That is a linear line. Y is equal to m into x square. It is a parabola. Or y is equal to m into x cube. It is a cubic variation. So constant, linear. So this is the way in which the variation will be happening. So this is the reason why for a UDL, the variation of the bending moment will be a parabolic variation. For in the case of a constant load, it will be a linear variation. Okay. Now let us do one complete problem, so that you will understand the complete essence of this topic. That is, so consider a beam like this. Okay. Here I am having loads. Here is a 10 kilonewton, then there is a 20 kilonewton, and here there is a 5 kilonewton, and let the distances be 2 meter and 1 meter. I am marking the points as A, B, C. Okay, I have marked the points. Now, first of all, shear force diagram. First of all, I am going to draw the shear force diagram. So for that, I have to draw the shear forces. So the shear forces, the shear force. So shear force at C is equal to, what is the shear force at C? It is 10 kilonewton, positive 10 kilonewton. Now shear force at B, what is the shear force at B? 10 plus 20, 10 plus 20, that is 30 kilonewton. And shear force at A, what will be that? 10 plus 20 is there, 10 plus 20 is there, plus what is the another thing is happening? A 5 kilonewton per meter load is there. That is, what will be the load? 5 into 2, that is the load. That is again 20, 10 into 20, the 30 plus 10, that is 30 plus 10, that is 40 kilonewton. So this is the load. So that is shear force today is 40 kilonewton. So I am just drawing the here everything will be positive only, because the right of, I am always considering the right of the section. So right of the section is if the force is downward, it is taken as positive. So I am just drawing the baseline. First I am drawing the baseline, and the first point it is 10. At this point it is 10. Then here it is 30, and the last one it is 40. So how can I join? I will be joining like this. So this you have to understand. So here there is UDL. So the UDL portion you have to join by a linear line, slanting line. Okay, sorry. Okay, this will be the variation. This is positive. This is the shear force diagram. So here there is straight line, and from here it is a linear line. So here it is 10 kilonewton, here there is 30 kilonewton, and here there is 40 kilonewton. Okay. Now next thing it is bending moment diagram. Okay. So bending moment diagram, first one, what will be the bending moment at C, this point? At C, what will be the bending? There will only one load, minus 10 is there, minus 10 into 0, that is again 0 kilonewton meter. Next one, it is bending moment at B. So bending moment at B means this is the point. So this is the point, and what is the load? Only two loads are, one is 20 into, that is you can take minus of 20 into 0, minus another load is 10 into, what is the distance? This distance, that is 1. So it will be minus 10 kilonewton meter. Now what is the bending moment at A? It will be, I am considering from this point. So this you have to clearly understand. There are, how many loads are there? 2 point loads and one. First one we are considering this point load 10. Okay, I'm first considering this load 10 kilonewton. So this is the direction. So this is the, so it will be moving down. So minus of what is the load? 10 into perpendicular distance is 2 plus 3, 1, that is 3. Then again minus due to, again it is in the clockwise only rotating, for minus of 20 into, this is the distance, 20 into 2. Okay, again it is not over. Again we are having another load, that is UDL. So UDL we are having 5 into 2. 5 into 2. This 5 into 2 will be acting at this point center. So this will be the point of application of the load, center. Okay, that will be into, what is the distance we will be getting? Distance will be 1. So this is the total bending moment at A. 30, 40, 70, 80. That is minus 80 kilonewton meter. So this is the bending moment at A. So I'm just drawing the diagram. Here first one it will be 0. At B it is 10 kilonewton, 10 kilonewton meter, and the last one it is 80 kilonewton meter. So here I will be joining by a straight line, and here it will be a parabolic line. Okay, so this is our shear force bending moment diagram. So this is a straight line and this is a parabolic line. Okay, now consider, just look at these two figures. Now here, when there is a horizontal line, when there is a straight line in this shear force diagram, that at the same region there will be a linear line in the bending moment diagram. And when there is a linear line in the shear force diagram, there will be a parabolic line in the bending moment diagram. That is, the few minutes ago I have said, a straight line. What is the equation of a straight line? Y is equal to m, a constant. That is equation. If this is the shear force, and this bending moment will be y is equal to m into x. That is this straight line. And if the shear force is y is equal to m into x, what will be the bending moment? It will be y is equal to m into x square. That is, shear force will be the higher of, bending moment will be the next higher degree of the shear force diagram. Okay, if shear force is constant, bending moment will be linear, and likewise. Okay, again one more sample problem we will do. That is, considering a UDL like this. So here, this is 5 kilonewton, this is 2 kilonewton, and let this be 2 meter, 2 meter, and 4 meters. Okay. So I'm just numbering it as A, B, C, D. So just understand the naming. Sometimes the naming will not be given. The points will not be marked. You have to mark it. So just understand what are the important points here starting. Then when a load is ending. Then again a load is coming. Like that points only you have to mark. So first one we can find out the shear force. So shear forces. So shear force at D. So the shear force at D will be, again here it is a UDL. This is per kilonewton meter. Sorry, that is 2 kilonewton per meter into what's the distance? It is 0. So that will be 0 kilonewton. Now the shear force at C. What is the shear force at C? It is a total load. That is 2 into 4. That is 8 kilonewton. 2 into 4. Then shear force at B. What will be that? 2 into 4 is there. That is, we are considering to this section. From this section plus 5. That is 8 plus 5. That is 13 kilonewton. And again shear force at A, it is same only. 2 into 4 plus 5. That is 13 kilonewton. So I am drawing the shear force diagram. The baseline is drawn, or everything is positive only. Therefore here it is 0. Marking here. then it is here it is 8 kilonewton, then there is 13, and then there is 30. So how can I join this? This will be a linear straight line. From here it will be a constant, again a constant, like this. So this will be, so here it is a linear, here it's a constant line, because in below the or in the, for a region of UDL it will be a linear, and other for a constant load it will be a constant line only. So this is our shear force diagram, SFD. Okay, I'm just hatching the portion also. Now it is our point, bending moment. So bending moment, again I am starting from this end. Bending moment at D. Bending moment at D is equal to, again at this point it will be 0. Then bending moment to C. What will be the bending moment at C? I am considering this section bending moment. So I have to consider to the right I am taking. So what is the load that is coming? Minus I am taking, because it is clockwise only. Right is clockwise, therefore minus is taken. Minus 2 into 4, that is the load. And where it will be acting? This will be acting at the center. That load will be, that is our assumption. And what will be the distance? It will be this distance from the C to this is total load. That will be 2. So 2 into 4 into 2. This is the load into perpendicular distance. So what will be the answer? 8 into 2 minus 16 kilonewton meter. Now bending moment at B. Again bending moment at B. That is from here I am considering. Bending moment at B. So bending moment at B means what are the loads are happening? 5 kilonewton is acting at that point. Therefore there will be no load. Now only due to this UDL there will be load. That is minus of, again the load is 2 into 4. 2 into 4. Now what is the distance? Distance means, this one you have to clearly understand. Distance means it is from this point to this point. This is the distance what I have drawn here. So what is the distance? That is, this is the load, 2 into 4. 2 into 4 into distance means it is 2. This is 2 meter. Again 2. So the distance will be 2 plus 2. So this will be the total moment. That is 8 into 4. That is minus 32 kilonewton meter. This you have to clearly understand. That is the bending moment at B. Now again, the bending moment at A. That is the next thing. Bending moment at A means from this point we are considering to the right. So what are the loads? First one is 5 kilonewton is there. That is minus of 5 into. The distance is the small distance. This is the distance. That is 2. 5 into 2. That we have obtained. Next one is a UDL. UDL again the load is 2 into 4. That is 8. What is the distance? That is from this point to this point. That is 2 plus 2 plus this 2. 2 plus 2 plus 2. Okay, so this is the total. That is, here it will be getting minus 10 minus of 8 into 6. That is 48 is there. So we will be getting minus 58 kilonewton meter. So this will be the bending moment. So if I am drawing the bending moment diagram, I can draw the bending moment diagram like this. That is, I am having here it is 0. Then in the shear force, I am at C it is 16. It is 16. Now again at again here it is 32. The last one it is 58. So this is my diagram. So here you can understand that here itself it is parabola, and again every point the full will be always parabola will be there. So this will be our, because understand that because in the last problem we have done the UDL was here, but in the initial portion there was no UDL. But considering this figure, at every point from C, B, A, everywhere UDL is there. Therefore, every time there will be a parabola, a square term is there. Therefore, total will be, all will be a parabola. So here it will be 16 kilonewton meter. This is 32 kilonewton meter, and here it will be 58 kilonewton meter. So this is the way in which we can find out the bending moment and shear force diagram, okay, of a cantilever. Now we have to, in cantilever, one more small topic is there, that is a cantilever. We are having a cantilever like this, and it is subjected to a UVL, uniformly varying load, like this. Okay, let that load be 10 kilonewton per meter, and let the distance be 2 meter. Okay, so A, B, I am taking C. Let that point be what from 1 meter. 1 meter. So first of all, I have to find the shear force. Again, shear force at B is equal to 0 because there is no. Then what is the shear force at A? Shear force at A is equal to, shear force at C. Shear force at C will be, what will be the shear force here? It will be the area of the, what is the area of a rectangle? This is the area of this figure, this area. So area will be this one, this area which is marked in blue. So shear force at A is equal, shear force at C is equal to this area. Area means half into base into it. Half into, what is the base? That is 1 meter. 1 meter into 10 kilonewton per meter. That is, it will be half into 10, 5 kilonewton. This will be the shear force at C. What is the shear force at A? Shear force at A will be again the area of this whole triangle. That is half into 2 into 10. That is 10 kilonewton per meter. So we can draw the shear force diagram like this. It will be a parabola only. It will be a parabola. Shear force diagram itself will be a parabola. Parabolic, because what is the reason? For example, I am taking instead of that I am taking W kilonewton per meter. Therefore, what will be the force here? It will be W into X into X. That is half into base into it. W is W into X square. So W into X square, it is a equation for a parabola here. So that is the reason why shear force will be parabolic. Now considering the bending moment. Bending moment at B will be 0. Bending moment at B at this point will be 0. Now the bending moment at C. What is the bending moment at C? That is load into perpendicular distance. Minus of, what is the load? Half into area. Half into base into height. Okay. This one into, what is this load is will be acting at the centroid. This load half into 1 into 10 will be acting here. This 5 kilonewton will be acting here. So what is the distance? Is a centroid. This distance will be 1/3 of this height. That is 1/3 into 1. So we will be getting it as 5/3 kilonewton meter. Now the bending moment at A will be, what is the bending moment at A? Bending moment at A will be minus of half into 2 into 10 into 1/3 of, so this is the total load. What load will be acting here when considering the total section? So this load will be acting, and that distance will be this distance. That will be 1/3 of 2. Okay, so we will be getting 20/3 kilonewton per meter. So the diagram will be like this. Here it will be 5/3. Here will be 20/3. So these can be so this variation should be joined like this, that is there will be a cubical variation. Sorry, there will be a cubical variation. Okay, this will be cubical variation. Okay, so that is a change when a UVL is coming, uniformly varying load is coming. So just summing up the this things in a cantilever beam, when considering that is, if I am loading, shear force and bending moment. So just to understand, first one, it is the point load or concentrated load. Shear force will be straight, bending moment will be linear. Next one, it is the UDL. Here shear force will be linear, but the bending moment will be parabolic. It will be linear. Okay, and considering the UVL, it will be parabolic, and this one will be cubic. This one will be parabolic, and this variation will be cubic. So what is the change? If I am having, for this equation is y is equal to m. For this equation is y is equal to m into x. Here it is y is equal to m into x. It will be y is equal to m into x square. Here it will be y is equal to m into x square, and here y is equal to m into x cube. So this is the reason, that is, the shear force will be the higher of the bending moment will be the higher degree of the shear force. So that is the only thing you have to understand while drawing. So these are the things which we have to understand in the while studying the shear force and bending moment. And by the two classes we have now studied the shear force and bending moment of a cantilever beam under various loading conditions. And the only thing you have to understand about a cantilever beam is that if I am having a cantilever beam like this, and there is some type of loading, is there, you have to start from the free end. From the free end you have to start, and then you can easily find out the shear force and bending moment diagram. Okay, from the free end only you have to start. Then another thing is that in some problems, I will just show one problem. So mainly you have to understand that from the free end only you have to draw the shear force and bending moment diagram, and okay. So a lot of problems have been written here. Look at it, you can see here there is a UDL is throughout, then a point load is there, so you can just understand it is explained a combination of loads will be there, UDL and UVL can come. Here you can understand in the case of point load, this is the shear force diagram, and the bending moment diagram will be like this. So always try to draw the beam first, and after that you try to draw the bending moment diagram. So for example, in this beam, first draw the shear force diagram to its right bottom, then draw the bending moment diagram. So in this order you can draw, and you can write the values in the right side. Here you can just write the shear force values in each point and the bending moment. This is the only thing you have to understand. No need to write essays and all. Just draw the figure in the left side of the page. Left side means center side, and to the right side, take 1/4 of this end. To the right side, just write shear force at A, shear force at B. Write the values, and just the small steps. Likewise, bending moment, write the values. Only that way of writing is needed to solve this problem. No need to write so many of explanations, etc., as it is given in this note. This note, it will give an idea about taking the section, etc., but the major thing it is just to understand each section and to. So we will discuss more problems, sample problems from this in the coming classes about the simply supported and overhanging beam. Now you have to understand, you have to study about the simply supported and overhanging beam. That will be covering in the next coming classes. Okay, thank you.